Today we are doing 3.1 flipping the grid, coordinate rules for reflection. We know what reflection is, we know how to do it with a line of reflection or two items that are already reflected, and we have to find the line of reflection. We can draw a reflective image given a line, etc. We have all those skills. Now we're actually going to put it on a coordinate grid and see what the rules are. So today, or the day you have my class, will be March 9th. 3.1 flipping the grid on the coordinate rules for reflection. I have to go look at the page numbers again. My book went missing sometime in the last unit, so we'll fill this in as soon as we can. Make sure you write this into your table of contents nice and neat, please. And we're showing butterfly, pinwheels, and wallpaper. The butterflies is the reflection section, so the butterfly part. Okay, so 3.1, flipping the grid on coordinate rules and reflection. The question states, how can you describe how points move under reflection with coordinate rules in the form x, y, and this is an arrow, to whatever the next 2 points are, the new x, y points, when the reflection line is 1, the x-axis, 2, the y-axis, and 3, the line x equals y. Sorry, there shouldn't be a parentheses there. So we're going to look for 3 lines, okay? And I'll briefly just draw the lines here. So the first line will be when the line of reflection is our x-axis. So when the line of reflection is here, so the first line of reflection we'll look at is this one. This is a pretty standard line of reflection, okay? The second line we're looking at is the y-axis. That's this one, okay? And the last line of reflection is actually going to be a diagonal. This is the line of reflection x, y equals x. This is when x is equal to 1. So every time I go over 1, I go up 1, over 1, up 1. I can go over 2, and then up 2. This line will represent y equals x. The y-intercept will be 0, but again, that's something that we don't really need to talk about. It's assumed because it's blank. Okay. So the first thing you're going to do is cut out your lab sheet 3.1 reflection. And we're going to complete the table showing the coordinate points A through E and their images under the reflection Y. So we're going to find these other 3 points C, D, and E. Okay, so point C, D, and E. So point C is, let's find each one. So point C is right there, which is 5, 4. This is 5, 4. Point D is over here, which is 6, 6, 6, 6, and I should have parentheses here. And the last point is E, which is 3, 6. So 3, 6. So those are my 3 points that are given to me, and what we're going to do is we're going to reflect this flag across the first point, the first line, which tells us it is the y-axis. So I'm going to make a line of reflection here. Okay, thin this line out a little bit. Okay, this is my first line of reflection right here. Okay, and with that line of reflection, I'm going to move this point over to this side, and I'm going to label my new points and come up with a statement. Okay, so I went ahead and reflected this flag drawing across the y-axis. So across this y-axis, these two are point B and B image are 2 spaces away. They hit at a 90-degree angle. E is 3 spaces away. D is 6 spaces away from the y-axis, just on the other side. Okay. Now we're going to start labeling these points. Okay, so what are valuing these points based off of their location, and we'll come up with a conjecture. So A doesn't move. That's 0, 0. That's a fairly rare occasion. Anything on the y-axis should stay on the y-axis in the same spot. Okay. Point B moves to -2, -2, 4. Point C moves to -5, 4, and point D moves to -6, 6, and point E moves to -3, 3. E image, sorry. Okay, So let's, what patterns do you recognize here? What changes? What stays the same? And what you notice is every single time, the only thing that changes is our x value. So our x value was 2, now it's -2. It was 5, now it's -5. It was 6, now it's -6. 3, now is -3. They all moved over to the opposite side. That negative sign, it does mean negative, but realistically it just means the opposite of. So this is no longer positive 2, it's the opposite of positive 2, not positive 5, but the opposite of positive 5, etc. So we can say that the rule is, okay, so we're going to write down this rule. So let's type this out. So when reflecting across, the y equals the y-axis, the rule is x comma y becomes negative x comma y. So the only thing that changes is your x value. It becomes negative or becomes the opposite. If it was in the negative region, the x's would still stay changed to negative. It would just be across the y value. So everything moves to the negative side. If it was over here and it was a negative value, it would be negative, negative, and move to the positive side. Okay, so this is important. This should be in your notes, highlighted, boxed, y-axis. The rule is x, y turns into negative x comma y. Okay, so we'll do the same thing. We'll do this with question B, which asks us the same thing, but this time the part that changes is our line of reflection changes to our x-axis instead of our y-axis. So our line of reflection is here now instead of our y-axis. Now it's our x. So let's identify our points first. I'll write them out here. We'll draw it, and then we'll flip it over. Okay, so here's our flipped over version of the flag across the x-axis. Here are our new points, A, B, C, D, and E image, and we'll fill this out so we can see what the values are and identify a pattern. Okay, so here are the points valued on the chart, all the image points after the reflection. So again, we'll identify the differences of the two. So here, the 0, 0 doesn't change anything. Again, it starts and ends in the same place. The B and the B image, the difference is in the y values. Those become the opposites now instead of the x's. So before it was a negative x. Oops, I gotta change that. Now it's going to be a negative y value when reflected across the x-axis. Okay, so let's write our rule down. When you reflect across the x-axis, the rule is x comma y, whatever your original points are, change to x comma the opposite of y. So it was 2, 4, now it's 2, negative 4. It was 5, 5, now it's 5, negative 5. Okay. Oh man, I gotta change this. This is 5, 4. Let's fix that. Sorry. It should be 4. And this should be 4. Sorry, that's probably the same issue on the other page too. I think I marked this point wrong. Oh no, I got it right. Okay. All right, so that's a 5, 4, not a 5, 5. Sorry. Okay, we'll do this one more time, and this time our line of reflection will be right over here. It's going to be across this way. So it's going to be a little bit different. We're going to see where the points lie and how they change and they vary. So not as simple as the other ones. So I'm going to go ahead and mark these points. They are the same as above. And then I'll flip it over and we'll mark the new points. Okay, so I have my line of reflection ready to go. I have my my flag marked off, and then now I'm going to flip it across that point and see where it lies. So I'm going to reflect across this line. They'll pretty much be on top of each other. The couple things I do know is that point D and point A, since they're both on the line, I don't expect those two to change. I expect B, C, and E to change. I don't expect D and A to change, again, because it is on the line of reflection itself. This is my line y equals x. Okay, so there's my flag flipped across my line y equals x. It's a little bit off, but not too bad. I put these points down so I can label everything. A stays the same spot. D, again, doesn't move. E goes from this corner to this corner, and C goes from this corner to this corner, and B is right down here. So now let's write the values of these points, and again, we'll look for a pattern, and we'll make a rule like we did before. Okay, the unique thing about this, even though everything's in quadrant 1, everything stayed positive. So it's really difficult to look at A and D because those stayed exactly the same. So let's look at B and C and E, B, C, and E. And actually, I marked this one incorrectly. This should be 4, 2, 4, 2. Okay, so these are our points, and let's look for the differences between the two. Now, in B, I had 2 and then 4, but here the 2 is on the other side. So I had blue, blue, green, and now I have green, blue. Let's look at C. I had 5 as my x, now my 5 is my y, and vice versa. My 4 was my y, and now it's my x. And I think that holds true here. 6 switches places, and the 3 switches places. Okay, it was difficult to see with the 6, 6 because they're exactly the same, and the 0, 0, they're exactly the same. So there wasn't very much change. But for the other ones, there was a change on the positions of the x's and the y's. So our rule, I had got it ready. So when reflecting across the, not the x-axis, but the y equals x line, the rule is xy, and it switches places. Now it becomes y, comma x. So the places change for those 2 points. Okay, so that is 3.1, flipping on a grid, coordinate rules for reflection. Okay, we did answer question A, B, and C. Okay, these rules need to be highlighted and remembered. Okay, well, not memorized. Sorry, I don't condone memorization. Understanding is, again, the more important of the two on how they work. If you know how to reflect, you should be able to identify some patterns between the two. Okay, so lastly, we're going to do the second part of your notes, which is always going to be the summary portion and the questioning portion. Okay, so you watched the video, you answered some questions along the way, you put in your notebook, you cut out the lab sheet, etc. We did all this stuff. Now, the ending part of your notes is always your summary and your questions. So the summary, again, you can write a general summary if you'd like to, but if you don't know what to write, here's some questions to guide you. What types of reflections did we cover, and why were those why did we only cover those specific lines? Why didn't we cover other lines? And what are the pitfalls of the other lines? If you reflected a figure that started in quadrant 2, the top left quadrant, so and you reflected it across the y equals x, the last one we did, which quadrant or where would it end up? Okay, why is it poorly asked question? How did investigation 1, measuring distance from a point to the line of reflection across and crossing at a 90-degree angle, help you in this investigation? 90 degree. There we go. Put a parentheses there. Okay, so when we started measuring things, we just started drawing items before we started coming up with exact points. How did measuring and hitting the line of reflection at a 90-degree angle help in this unit? Or did it help at all? And some questions. Again, write some questions that you might have about this section so that we could talk about them in class. Write questions that you think someone else would have, and what are some common mistakes that they might make. Or if you want a challenge question, if you reflected the same flag across the line y equals -x. So this is a different line. You're going to have to graph this line and then reflect it across that line and see what you end up with. How does it change, and how is it related to what we've already covered? Okay, This should all be written in your notebook, ready to go on Thursday.